No, you are, but just be very conscious.
People look
Don't
at the
make
YouTube,
noise.
they're like,
Okay.
No,
So anyway, coordination number of 6. Ready?
Yeah.
SF6, we saw that dot structure yesterday. That was our first real oddball. I'm not going to put all the lone pairs around the Fs. Yes, it would take less time.
I swear.
How are 6 bonding orbitals going to arrange themselves as far apart from one another as they can get?
Cubic.
Yeah. This one is nice because you're going to have the above and below. You'll have the left and the right. And you'll have the front and the back. This one is so good. But naming it is not so good.
ICL 3?
Yeah, what's the name of the shape?
Oh,
That's
T,
right, the
T.
X, Y, and Z coordinates.
T.
Okay, here it is, and here's a computer model of it. But what is the name? How do you name this thing? Here's how they named it. They imagined connecting all of the corners. And you see how that makes a triangle? And then over back here you'd have a triangle to those 3. And back here you'd have a triangle to those 3. It winds up, how many triangles could you make from all these? 8. You can make 8. Therefore, this is called an octahedral. Octahedral.
Oh, the cubic.
Wait, I swear I saw cubic.
We didn't make the rules. Somebody else made the rules. We just played by.
We're changing.
Yeah, we're changing it.
What is the bond angle?
90 degrees.
Make everything kiddish. FIFA.
Octahedral. 90. I'd say 120. Yes?
Was there anybody that calls it cubic?
Maybe. Probably somebody.
But I mean, like somebody respected.
Probably some fool.
So no respected people. All right.
Nobody respects me.
Okay.
Okay, how are we doing? Doing well. ICL5. To do the dot structure of ICL5, we would wind up with this. Yeah, you're going to have all 5 CLs attached to the I and then also a lone pair.
Yes.
It's getting pretty messy. So we have a coordination number of 6. There's 6 things around the I, 5 CLs and 1 lone pair. That means one of these needs to come off. It doesn't really matter in this case which one comes off because they're all 90 degrees from each other. Now what is the shape? A fan, yeah. This one is it's another pyramid.
Square.
But it's a square pyramid because it's got a 4-sided base, not a 3-sided base.
I like that.
So when we have a coordination number of 6 and there's 1 lone pair, that's a square pyramid. And I had a picture of that one too. Oops. I missed it. I'm trying. There it is, there's a square pyramid. Now we have one last one. What is the bond angle here? We have a lone pair down there that's spreading out. It's trying to push on 4 bonds. How's it going to do with that?
Horrible.
That are already trying to repel that one up there. Maybe a little bit of repulsion. Not much at all. Let's just say less than 90 and not give an actual number.
It's less than 90, like 89.
89.8 or whatever. 89 point, is there a good radio station, 89 point something, Lena?
Oh, I'm pretty sure.
89.9, that's what it is.
Wait, there's an 89.7, which is like classic,
Yeah.
classic like orchestra, right?
Let's go.
Okay. One last shape, right at the buzzer. I do feel like I'm ripping you off because I'm not letting you do the dot structures. But you'll get lots of practice when you do the whole.
Oh, gee, thank you
Do
so
it
much.
yeah.
Oh, Z non-touchable.
What did I feel if I called?
Yep, that's right.
ICL5, square pyramid.
So XEF4 looks like this. Okay, we're feeling pretty good about doing that way, but then we realize, oh gosh, I need 2 more lone pairs on there, and so it looks like this. Now, what is the shape? If we have a coordination number of 6, that means all the orbitals are 90 degrees from each other. Now we have to take 2 off. Okay, fine, take 1 off like that. Now, which other one do I take off? Do I take off the one that's the oddball, that's not in the plane with the rest of them, or do I take one of the planar ones?
The planar one.
Take the oddball off, yeah. Now, you should be able to, this is a square planar. They're all the same. And I love, this one is my favorite of the computer images that I found. Check this out. It looks like a spider. They kept the lone pairs on there, and yeah, with the little eyes.
Oh, Mr. Moore, spiders
Look at a
have
spider
8
looking in a
legs.
mirror.
Okay, it's an insect. It's an insect. We need this an insect. Calm down.
Bond angle is exactly 90 degrees.
You wanted to end the question.
I know, that's.
Okay, my dear friends, thank you for that. We're done.
What's it called?
Oh wait, can I
We
check
call
this
it
out?
insect.